Here we go with lesson 6 on modeling with linear functions. Some things to remember here: all linear models in the form y equals mx plus b have what we call two parameters. Okay, the first parameter is the slope m, and the second one is the y-intercept, or b. Okay, so the parameters are these things, the m and the b. Those parameters are, the slope tells us how fast the output is changing relative to the input, and the y-intercept is telling us how much we start with, in other words, when x equals 0, right? Because this is where, when x equals 0, that's where our line will cross the y-axis, right? So this value is always a starting point, and the m is how we are changing relative, how the output is changing relative to the input. Okay, so real world example, let's take a look at this. Jimmy has $100 in his bank account at the beginning of the year. He puts money into the account at a rate of $4 per week. We want to model the amount of money he has in savings, S, as a function of the number of weeks he has been saving, W. Okay, so we're coming up with a function in terms of S and W. Okay, some important things here. He has $100 in his bank account at the beginning of the year. So he's starting with $100 before any time passes. Okay, and he's putting money into the account at a rate of $4 per week. So every 1 week is $4. So we want to model the amount of money he has in savings, S, as a function of the number of weeks he has been saving, W. Let's take a look at this table. Complete the table for the given number of weeks. So at 0 weeks, let's think about this. If no time has passed, how much money would Jimmy have in his bank account? Well, we go back to this first sentence here. Jimmy has $100 in his bank account at the beginning of the year. So before any time has passed, he's going to start with $100 in the bank account. So his savings is going to be $100. All right, so let's start small here. We know he's going to have $100 to start with. And after 1 week, we're going to need to add $4 more, right? So for 1 week, we're going to add $4. So now he has $104. Well, so how do I know about after 5 weeks how much he has? Well, let's think about it. He starts, no matter what, he has that $100 he started with. And then he has $4 for every 5 weeks. So I could add 4 or 5 times, or as I just said, 4 5 times, right? So 4 times 5, and that's 20. So 100 plus 20 is going to be $120. Okay, and that same concept is going to apply down here for 10 weeks. So again, he had $100, and after 10 weeks, we could add 4 10 times. In other words, 10 times 4. So that's 40, so $140. All right, so let's try to use that information to write a function rule for the savings as a function of weeks. Okay, so what does that mean? That means S, we want S to be savings is the output, and W is the weeks is the input. All right, so function of savings as a function of weeks. So we have savings, and let's use this terminology, S of W. Okay? So savings, and then what do we need over here? Well, we would need how much he started with, right? So in order to find out how much he's making in W weeks, right? What over here in our table was the weeks? It was this, right? That's what's changing. I guess I could have had a 1 right there. Maybe even this, right? 100 plus how many weeks was 0, right? So let's take a look at that. What's changing? This value in the parentheses is what's changing each time, right? So that's our W. That's the weeks. So we have this formula here, 100 plus 4 times W, right? Or 4W. You could write it like this. S of W equals either 4W plus 100 or 100. You don't need the parentheses, plus 4W. So if Jimmy saved for 1 year, what is the range in his savings over the year. Okay, we remember this word range here, right? The range was the set of all y values, right? The y values are the outputs. So in other words, if he saved for a year, I'm looking at this column over here, the savings column. That's the output, right? So we want to know the minimum and the maximum. That would be the entire range for a year. So let's think about this. At 0 weeks, we already have that information right here. So the minimum value, the range, is going to be from 100. And now we got to find out how much he would have at the end of a year. Well, how many weeks are in a year? Let's use our equation over here. How many weeks are in a year? We know there's 52, right? So let's find S of 52, right? That's the weeks. We're just going to plug in this number now for the amount of weeks. S of 52 equals 100 plus 4 times, and instead of W, we have 52. All right, so S of 52 remember, that's how you say that. S of 52 is going to be 100 plus 4 times 52 is 208. And so S of 52 equals 308. So at 52 weeks, he has $308. So the range in his savings over the year is from $100 to $308. So from $100 to $308. And that's the range in y values. This is the minimum, and this is the max. Okay, so if I wanted to know what the value difference in the range was, I would subtract 100 from 308 and tell you that you are growing by $208, right? From 0 weeks to the 52nd week, the end of the year, you've grown $208. Okay, so range in his savings is from $100 to $308. Put dollar signs here. All right, so would it make sense to evaluate S of 6.5? Does that make sense? What does that mean? What does this number, this 6.5, represent? Right? We have to look back. That 6.5 is this number. It's the weeks, right? Or over here is that 52. So what would 6.5 mean? It would mean 6.5 weeks. Well, again, this is a real world example. So let's go back to the top. He puts money into the account at a rate of $4 every week. So is he stopping in on Wednesday and putting in $2? I don't think he is, right? Just every maybe Friday or every Saturday at the end of the week, he's putting in another $4. So you have to wait an entire week before the $4 goes in. Okay, so to me, I don't think this would make sense to evaluate 6.5 because Jimmy's not putting money in at half of a week, only on the whole numbers. Okay, so no, it does not make sense. Because Jimmy is not putting money in at half a week. And what is the average rate of change for this function? To find the average rate of change, what I'd want to do is remember our good old friend here, y equals mx plus b. Okay? And the average rate of change we know is the slope. So let's take this equation up here and make it look like y equals mx plus b. To do that, it would say S of w equals 4w plus 100. Okay, now 100 is like my b, w is like my x, and the 4 would be like the m. So the average rate of change for this function would be, we want it as a fraction, right? So it would be 4 over 1. And that means 4 weeks, right? Or I'm sorry, it's $4 per 1 week, right? That's the average rate of change. It's how this is changing, $4 every week. All right, let's go on to the next one. What happens if we don't have a starting value? In other words, we don't have that b term that we really want for our y equals mx plus b. All right, here's a real-world example where that would happen. A plane is flying at a constant speed towards Hawaii. After 2 hours of flying, the plane is 2,563 miles from Hawaii. After 4.5 hours, okay, let's do this, 2 hours, 2,563 miles. After 4.5 hours, the plane is 1,188 miles from Hawaii. So we're going to create 2 ordered pairs that summarize this information. Okay, and we're going to make make these ordered pairs in terms of hours and miles. So the first ordered pair is this one up here. After 2 hours, that many miles. So the first ordered pair is going to look like this: 2, 2,563. Remember, we want 2 ordered pairs. So the other ordered pair is going to look like this: 4.5 and 1,188. So I can do 4.5. That's 4.5. That's hours, and miles is 1188. 1,188. All right, that's not too bad. So now I have 2 points. I could call this one, if I wanted to, x1 and y1, and I could call this other one x2 and y2, just to keep things straight. I want to calculate, remember this? What this means? Calculate triangle D over triangle H. That's delta D over delta H. That means the change in D over the change in H. And I believe D and H here is probably going to be distance and hours. That's what's going to make sense. So the change in distance over the change in hours. Well, think about it. This was miles, and that's a distance. That's my y values. And this here is the time. Okay, so that's the hours, and those are my x values. So we have the change in y over the change in x. So in essence, we're trying to calculate the slope, right, of our line. All right, so let's do it. So change in y over change in x. We have 2,563 minus 1,188. Those are my y values. And the x values are 2 minus 4.5. And let's see what that equals. When I subtract the top, I get 1,375. And when I subtract the bottom, I get negative 2.5. So when I clean this up a little bit, and I divide 1,375 divided by negative 2.5, I'm going to get a negative 550. And since I want this to be my slope still, let's keep that over 1. Negative 550 over 1. So what does this really mean? What was the slope here? This is the average rate of change. This is my, what was the label in the top? This was miles. And what was in the bottom? The x values were hours. So look at that. That's 550 miles per hour. But we have a negative slope here. So why is the average rate of change negative? Did we do something wrong, or is that okay? What we want to do is physically think about what's happening that's resulting in this negative rate of change. Okay, let's go back to the question. This plane is flying at a constant speed towards Hawaii. Okay, maybe we're starting in New York. Well, that's a terrible picture of New York. Like that. right? And Hawaii is way over here, a bunch of little islands, right? And we're flying along, we're going this way. Okay, at some point after 2 hours, maybe I'm right here. And I'm still going this way. And then after 4.5 hours, maybe I'm right here, and I'm still going this way. So what's happening to this distance each time the hours are increasing? So as the amount of time increases, the distance is decreasing. Okay, and we saw this with our scatter plots. As one thing increases, if the other thing decreases, let me just kind of make a little graph down here. As the hours, if those go up, as the distance goes down, then I'm going to end up with what we would call before a negative correlation, right? As the hours are getting bigger, right? So at this many hours, the distance is small. In the beginning, this many hours, the distance is large. So this is, remember, this is a negative correlation. Which means it's a negative slope. And that's exactly what we got up here. We got a negative slope. So we didn't make a mistake. Things are going the right direction. We're doing the right thing here. This rate of change should be negative. Okay, let me erase my horrible drawing over here. Looks more like a nose or something than a New York State. All right, so let's write a function rule for the distance d as a function of the number of hours h. All right, we're going to write a function rule now, right? So what does that mean? The distance is going to be our output, and the hours are going to be the input, okay? D as a function of h. So we could write it in our new notation here, d of h, d of h, which means the h is going to be the variable on this right-hand side as we go along. Here's the thing, though. I think I might be missing some stuff to do this. I need to figure out my b value, don't I? I can't quite do this yet because what I'm going to have is my slope, which is this negative 550 over 1, times the amount of hours, and then usually I have this like plus b, right? Or in the regular formula, the y equals mx plus b, and I know my starting value is not 0. I didn't start at 0 miles. Okay, the miles are, I have no idea how many miles, how long the whole trip was. So I need to try and figure this out somehow. And the way I'm going to do that is I'm going to plug in numbers that I do know. In other words, let's use one of these points that I already knew. So the distance, when I was at a distance of 2,563 feet, or miles, I'm sorry, I had flown for 2 hours. So the hours is 2. And let's put this plus b because I'm looking for it. Now let's solve for b. This tells me 2,563 equals negative 550 times 2 is negative 1,100 plus b. I need to add this to both sides to get b by itself. And I get 3,663 equals b. So what does that tell me? Now I can go back up here to my equation up here, and I can put in what that b value was. So that b value is actually plus 3,663. That's miles, right? That was my starting value, right? And let's look back down at our kind of little scratched up graph down here. Think about it. The y-intercept was going to be way up here somewhere. Not at 0, it's going to be way up high, and we're going to kind of approach a distance of 0, right? When we land, we are 0 miles from Hawaii. When we start, we are as far away from Hawaii as possible. Okay? So how far did the plane start away from Hawaii? Boom. It must be that. That's the starting point, right? We started 3,663 miles from Hawaii. And how long is the flight to Hawaii? So what are we looking for now? How long? We're looking for a time. Let's use our function. the one that we created. This is a function rule. Let's use this to find out our time. So in other words, we want to solve for h. How long is the flight to Hawaii? So what is the distance when we land in Hawaii? The distance, how far away are we to Hawaii when we land in Hawaii? Hopefully we are 0 miles from Hawaii. Otherwise something went terribly wrong on our flight. All right? And if the rate was negative 550 miles per hour, I want to solve for h, so the h is still here, and I started at 3,663 miles. Let's find out what h is when the distance is 0. In other words, we landed in Hawaii. So how long was the flight? To do this, first I need to use, remember we're doing PEMDAS backwards here. So let's subtract this 3,663 to both sides. Now I have negative 3,663 equals negative 550 times h. I don't need this over 1 anymore. Now I have multiplication going on. To undo multiplication, I'm going to divide. Okay, let's bring all this work over here. What happened? These cross off, leaving me with just h. And negative 3,663 divided by a negative 550 gives me approximately 6.7. And so that tells me it took about 6.7 hours to get to Hawaii. All right. A lot of stuff going on here, okay? So make sure you go back, you follow through what we were doing, try to make the connections as best as possible. Okay, remember what this was called. This was when we did not have a starting value. In other words, we were looking for the b in y equals mx plus b, right? No starting value, we're looking for the b, and that's what we did right here. We used a point, we plugged it in, and we found our b. All right, time to check your understanding. If you leave class early to go to your locker, which is 23 feet away from your classroom, okay, then while you are at your locker, the bell rang, and you begin walking to your next class. So you're walking away from your locker at a rate of 5 feet per second. Create a function rule that gives your distance away from your first classroom, d, in terms of t seconds. Okay? So we want to find out how far we are away from our classroom. Don't forget, we start at a different spot. We're not starting at the classroom, okay? And we want to create a function rule, d in terms of t. In other words, something you could make that looks like this. D of t equals something, 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 something. Okay? And the t would be over here in this something somewhere. The t is over there somewhere. All right? Go ahead. You try this. Don't leave it blank. Come back in with something tomorrow, okay? Next class, make sure you try something. Give me some sort of work. Don't just come and say, I don't get it. All right? Bring it in, and I will talk to you guys next class. See ya.